Let's delve into the fascinating world of atoms, the fundamental building blocks of all matter. Imagine, if you will, a time around 400 BC, when early Indian and Greek philosophers first speculated about the existence of atoms. They envisioned these tiny, indivisible units as the most basic components of the universe. Fast forward to 1808, where John Dalton brought a revolutionary perspective with his atomic theory. Dalton proposed that atoms are the ultimate particles of matter, foundational in explaining the laws of conservation of mass, constant composition, and multiple proportions. However, it's crucial to note that Dalton's theory had its limitations. For instance, it couldn't explain the electrical phenomena observed in substances like glass and ebonite. As the 19th century waned and the 20th began, scientists embarked on experiments that would challenge Dalton's foundational atomic theory. These experimental observations were groundbreaking, revealing that atoms are not indivisible after all. They are composed of subatomic particles. In 1897, J.J. Thomson discovered electrons through his cathode ray tube experiments. Then, in 1911, Ernest Rutherford identified protons during his famous gold foil experiment. And finally, in 1932, James Chadwick discovered neutrons, completing the trio of subatomic particles that compose an atom. Let's delve into the modern atomic model, which has reshaped our understanding of the atom's structure. At the core, we find the nucleus, a densely packed center containing protons and neutrons. Surrounding this nucleus is what we call the electron cloud, where electrons are not confined to fixed paths but move within areas known as orbitals. This model highlights the complex and dynamic nature of atomic structure. The understanding of atomic structure has, without a doubt, revolutionized numerous fields of science and technology. In chemistry, it provides a fundamental explanation for chemical reactions and bonding. Physics has been enriched with deeper insights into quantum mechanics and nuclear reactions. Moreover, this knowledge has propelled forward advancements in diverse technological fields, such as materials science, electronics, and even medicine, showcasing the profound impact of atomic theory. To summarize, the journey from ancient philosophical conjectures to Dalton's foundational atomic theory, and on to the discovery of subatomic particles, has been long and filled with groundbreaking moments. Our current understanding of atoms is the result of centuries of scientific inquiry and relentless experimentation. This evolution of thought showcases the persistent curiosity and rigorous investigation that drives scientific progress. I invite you to explore further into the fascinating world of atoms. Their profound role in shaping our understanding of the universe is a testament to the wonders of scientific exploration. As we continue to uncover the mysteries of the atom, let us appreciate how far we've come and imagine the possibilities that lie ahead.